Hello and welcome to Long COVID Foundation podcast. This is the channel where we share educational information on long COVID to help you understand your symptoms better. So if you want to have answers, please watch this talk from start to finish because we will help you to learn more. And just very quickly, if you're new to the channel, make sure you hit the subscribe button because I can then help you get answers relevant to your symptoms. And don't forget to get video a like because this tells me that these videos are useful. And at the same time, it motivates me to create more content for you. Thank you very much. And let's jump straight into our interview. Hello and welcome to Long COVID Foundation podcast. And today it's my pleasure to introduce you Professor Resia Pretorius. She's a head of department and a distinguished research professor in Physiological Sciences Department, Faculty of Science, Stellenbosch University, South Africa. So Professor Pretorius' research covers blood coagulation, circulating inflammatory markers, and how this play a role in inflammatory conditions like type 2 diabetes, rheumatoid arthritis, psoriasis, and neuroinflammatory conditions like Parkinson's disease and Alzheimer's disease. In the past year, Professor Pretorius worked tirelessly to understand long COVID. So Professor Pretorius, thank you very much for being with us. It's such a great honor to have you on our channel.
Thank you very much for the invitation.
So before I will go into discussing specific coagulation findings that you worked over the year, let me remind to our listeners that after an acute COVID phase, mild or severe, there are over 30% of people who still have lingering symptoms, which persist for as long as 6 months or even a year. So these symptoms include fatigue or muscle weakness, people are out of breath, they have sleep difficulties, anxiety or depression. However, there is still no clear answer why this happened. So we aim to shape the definition of long COVID, relying not just on the length of these persistent symptoms, but on something more specific, identified in blood, tissue, so that biomarkers are identified and medical practitioners are in a position to develop treatment protocols and offer appropriate medical care to those who suffer with long COVID. So, Professor Pretorius, could you please give a little bit of background on how you started researching long COVID?
Thank you very much for the introduction. Yes, so long COVID, as you mentioned, is a phenotype of acute COVID. So last year, when the acute COVID pandemic started also in South Africa, and because of the fact that I look at coagulation and blood clotting, and one of my well-known South African clinicians, Dr. Coagulation, treated some of these patients in the acute phase. We started looking at treatment options via Dr. Yaku, and then him in particular looked at that. And he also then, together with myself, looked more on a research level at the blood samples of acute COVID patients. So in those blood samples of the acute patients, we did identify microclots in circulation early in the pandemic already, and we published on that. And we also showed that there is significant platelet hyperactivation, or it means that the platelets are not healthy anymore. They are, instead of little round ball structures, they become these big spreaded platelets, they clump together, and that is a sign of significant platelet pathology. So around about middle December or so, I spoke to a very good friend of mine, Dr. Amy Proel, who also mentioned that she's been noting the phenotype long COVID in various patients that did not recover fully from acute COVID. At that stage, I also mentioned it to Dr. Loubser, And he saw then that there were significant people coming to his practice that were not treated by him during the early acute phase, but were now suffering from long COVID. We then started to look at these individuals as well. And the same pattern emerged, where we saw microclots in circulation, as well as platelet hyperactivation. So that is how I started looking at long COVID right in the beginning of the pandemic, first focusing on acute COVID.
So how was the development of the pandemic in South Africa from the beginning up until now? So what is the current situation with long COVID over there?
The long COVID issue is like in the rest of the world, in South Africa, also a major issue. I do believe that there's probably, as you mentioned, 25 to 35% of individuals recovering from the infective stage, but not recovering from the full spectrum of various symptoms that you mentioned, including brain fog, concentration issues, muscle pain, and then sudden pains on the chest. As you mentioned, there are numerous such symptoms, and I do think it's not different in South Africa than in the rest of the world.
So you mentioned your recent publication, and I will read the title, is Persistent Clotting Protein Pathology in Long COVID, as accompanied by increased levels of antiplasmin. So you mentioned that people with long COVID in plasma, you found large amount of microclots, and these microclots are resistant to fibrinolysis. So given that blood clots can block microcapillaries and thereby inhibit oxygen exchange, can this be a reason to these persistent symptoms? And could you please talk us through your findings in that publication?
The publication that you mentioned was done early in February, March of this year on a small population of individuals that were healthy and they never had COVID before, and they were also not vaccinated. Then also a group of patients that we collected the samples and stored long before COVID times that had diabetes, type 2 diabetes, and then a population of acute COVID that we stored the blood samples, and also storage of long COVID plasma samples. In this research that we then did, we wanted to find out which molecules that we could identify in the samples between the groups that are different between the groups. And we included type 2 diabetes because we know they are more prone to develop severe symptoms if they develop acute COVID. So that was our reason for including type 2 diabetes. To our surprise, when we did the initial laboratory preparation of our samples for proteomics, where we use a mass spectrometer to identify the molecules in a specific sample, we needed to digest the plasma. And to our surprise, we could not digest the plasma from the acute COVID or the long COVID patients using a trypsinization step. So trypsin is an enzyme, and it's well known that it digests any protein, but we could in fact not digest the two samples from the acute COVID or from the long COVID. We looked into a further process, and together with Dr. Marie Vlok, who is a biochemist and who works at our central analytical facility and is the main biochemist there at the proteomics lab, we then put the samples through a second trypsin step, and then we could digest the microclots. So we then did the analysis, the proteomics analysis, between the equivalent volumes of plasma that were digested from controls and from diabetes, and then also the now digested same volume of the acute COVID and the patients with long COVID. And in those populations, we then determined differences between what is left in the digested plasma of the various groups versus the control plasma and the diabetes. In these digested samples, we then found that there were molecules, including alpha-2 antiplasmin, that when we looked further into this molecule, realized that when it is present, it prevents clots from breaking up. So it prevents lysis. So inside the clots were also a plethora of various inflammatory molecules. Now, one of the issues that patients have is that when they go to their clinicians and they ask for pathology tests, regular pathology tests that you would do at a pathology laboratory, then these tests mostly come back as if the patients are healthy.
Exactly. Yes. So this is what I wanted to ask. Why then, if you found this significant coagulation happening in long COVID patients, why general tests do not show that there is an issue with coagulation? Even D-dimer tests, everything comes normal and people are concerned. So,
but the answer is very simple. The D-dimer, the massive inflammatory molecule presence of von Willebrand are all trapped inside the microclots that are the insoluble part of the plasma. And most of these pathology tests look at the soluble part of the plasma. So the soluble part, if you compare soluble with soluble, you don't find differences. And we also confirmed that there's no real, you do not really find differences when you simply look at the soluble part of this, the soluble protein content. So when you look at if you can somehow break open the microclots that are in the circulation, you will then find all the trapped molecules that you're looking at. D-dimer and different fibrinogen components, the chains, the gamma chain, the alpha chain, the beta chain, are all trapped inside these microclots. So the microclots are little inert areas circulating in the patient, attaching to the endothelial cells, attaching to platelets. The platelets are hyperactivated. It can eventually lead to endothelial damage. And many people have said that in acute COVID, patients have a endothelitis or inflammation of the endothelial layers. And we see that because if microclots are present, if platelet hyperactivation are present, you will find a constant endothelial damage and pathology. So important for us as well then is if you look at the presence of these microclots, as you rightly mentioned, if they are in circulation, they can actually go and block many of the fine vasculature in the individual body. And it can even cause the different symptoms that we see, because the patient, the cells of the various systems, of the muscles, of the brain even, perhaps do not get enough oxygen. So if there's a blocking due to the microclots, even if it's the very fine capillaries, you will have a constant state of oxygen deprivation of these patients. So many of the symptoms might be traced back to oxygen deprivation. So if one can remove the microclots and one can calm down the platelets, then you will see a positive result. And that is probably why Dr. Beate Jager's apheresis system works, because it removes the clot load from the patient, and it allows the oxygen flow to the various organ systems to be restored. And that is the very simple reason why we do not see necessarily changes in pathology tests. But when we look on a microscopy level, or a more detailed level inside the blood, then you do see these pathologies.
So, as you mentioned, with Dr. Jager's help apheresis, we had an initial interview when she was just starting to apply apheresis to long COVID sufferers. And at that time, we didn't have answers why it works on some people and not necessarily works on another. And this group of people who didn't feel instant effect of hyperpharesis were people with neurological symptoms. Could you please give your view why it may not be applicable to those?
So just a disclaimer here, I am not a clinician and I'm also not a neurologist. So I cannot give you a clear answer to that. However, what I can tell you is that we know that if the brain has got, the blood-brain barrier is damaged, which can happen because it's also just a vasculature area in simple terms. Obviously, it's much more complicated than that, but it's vasculature which can be damaged. And if it was damaged for months on end, with some people suffering from the symptoms for over a year, in 8 months even, I've heard some people suffering from long COVID since the first wave in early last year. The damage of the endothelial layers, the microclotting, the platelets can affect the blood-brain barrier. And then it will allow toxins, inflammatory biomarkers, molecules to enter into the brain area, and that can also cause the different symptoms like brain fog and the concentration issues. So my only thoughts about that is it takes much longer to heal the blood-brain barrier, to prevent the microclots, the platelet hyperactivation that happens to cause these symptoms, and also hypoxia that might happen in the brain tissue as well due to oxygen deprivation. So from a research point of view, I think it is much easier to remove the clot load, and you will see quite an immediate effect on a reoxygenization of the tissues of the muscle, but perhaps the brain fog and those areas, or the symptoms associated with brain dysfunction might take a bit longer. And perhaps the answer is a combination of anticoagulation therapy, like molecules carbon platelets, and removing microclots, as well as apheresis. That might be an option to see a quicker effect. But on that note, I'm not going to go too much into the treatment regime because I'm not a clinician.
Sure, sure. So in terms of research that you have been doing with Dr. Jaeger and bloods that you were looking for, and perhaps your hypothesis, what's going on. So could you give us your feeling why people develop long COVID and what makes people be vulnerable to long COVID?
From a research point of view, I think my opinion is that it might be individuals who, as I mentioned, when they had acute COVID, when there will be microclotting, and we have seen that, and many other people have also noted a hypercoagulable and platelet hyperactivation phase in individuals when they have got acute COVID. I think that those individuals never recover fully. So they are not treated, those symptoms are not treated fully when they have acute COVID, and therefore the symptoms just persist on. In some individuals that recover fully, they probably, they might have the microclotting, the platelet hyperactivation, as well as the possible endothelial damage that might be prevalent during the acute phase, or just dissipate and become better with either some other kind of treatment that they have, or because their bodies are just genetically more prone not to be affected by vascular complications like platelet hyperactivation and microclotting. It might be somewhere in between. There might be a genetic predisposition to someone that are more prone to vascular disease. And also what we we have been noting in South Africa is that many of the people suffering from long COVID also have many comorbidities, and that might include high blood pressure, diabetes, and things like too high cholesterol. But obviously there is a population that do not have one of those things. They don't have these comorbidities, but there might be some or other underlying symptom that was present before they developed acute COVID. So the quick answer is, it is I believe a vasculature and clotting and coagulation disease that does not go away or recover after the acute phase, and the person just goes on with these persistent symptoms that never gets better, because obviously they do not have the correct treatment.
So I hope this research that you are doing on long COVID patients and the blood samples that you have collected in Germany, I think it may help us to identify these biomarkers that could then be used to define long COVID, because what we see now, long COVID is defined in terms of the length of your symptoms, so how long you have the symptoms for after acute phase. And I think it is completely wrong. There is something really behind an illness. As with any other illnesses, there should be biomarkers and appropriate treatment protocols attached to that. So what is your opinion in terms of definition of long COVID?
Our definition of long COVID is a persistent presence of microclotting and platelet hyperactivation that do not disappear over time. And unfortunately, it seems that there's a percentage of individuals that will have this condition as a chronic condition if not treated adequately. So obviously one must have a definition of time linked to it. One cannot say a person has got long COVID a week or so after acute COVID, and I think the WHO definition is 3 months after recovery from the infective acute COVID stage. However, I do not think a definition of time is an adequate definition of the disease. It must be linked to biomarkers, and according to our insights, the biomarker is platelet hyperactivation, hyperactivated or damaged platelets, together with microclots in circulation, and then in addition to that, a damaged endothelial layer. But that must now obviously be further investigated by other researchers and also by us ourselves.
Thank you very much for this great insight about the work that you do, and I'm sure people will wait for your results and your publication that you're working on with your colleagues, and we'll be waiting for your results to be published and discuss these results, and most probably hopefully celebrate that we finally found some commonalities among these people who suffer different symptoms at different times, which is still a question. So thank you so much for sharing your experience with us.
Thank you very much. And I just would like to end off by saying that I've really got sympathy for all the various patients suffering from all of these symptoms. And I must just also say, it is definitely not a psychological disease. This is a real disease with real symptoms and real people suffering from it. And we need to get an answer very soon for all of the millions of people that are suffering currently. And with the different waves and new variants coming to our country and to the rest of the world, we need to really look at this as a matter of urgency.
Thank you so much for your time. Thank you, and bye-bye.
Bye-bye.